Hello students, welcome to my YouTube channel Rapid Chemistry. I am Ranjan Dash. Today would like to discuss a new chapter from your syllabus ICSE Concise Chemistry, chapter number 4, Analytical Chemistry. Analytical Chemistry. Before we start what analytical chemistry is all about, we must have to define analytical chemistry and the range of the chapter with which we will deal mainly today. What is analytical chemistry?
According to Wikipedia, analytical chemistry studies and uses instruments and methods used to separate, identify, and quantify matter.
Separate, identify, and quantify matter. So, analytical chemistry is a branch of chemistry that deals with the separation, identification, and determination of component in a sample. But here in class 10, in this chapter, we will mainly do the determination and identification of a radical through this chapter. And here generally we will use two chemical reagents, and one is sodium hydroxide, strong alkali, and another is weak alkali, ammonium hydroxide. With these two samples, and we'll identify different radicals, mainly their color, with their color and the solubility test. Okay. Determination of the chemical component in a given sample is called analysis. In chemistry, we study two types of analysis. The one is qualitative analysis, and which involves the identification of the unknown substance, and quantitative analysis, which involves the determination of composition of a mixture. But here in this part, mainly our study is related with the qualitative analysis. In the next class or after 12, you will do quantitative analysis. So here we will start qualitative analysis. Before we enter into the main topic, we have to know some prior information from this chapter, and that is some colorless ions. Ammonium ion, sodium ion, potassium ion, calcium ion, magnesium ion, aluminium ion, lead ion, zinc ion, all these are colorless ion. Okay, so these are the colorless cations, and the colorless anions are these are. So chloride, sulphate, carbonate, nitrate, bicarbonate or hydrogen carbonate, sulphide, bromide, acetate, these are all colorless ions. So you must have to memorize which are the colorless ions. Okay, and after that you have to remember the colored ions. So colored ions, you know, the cupric ion Cu2 plus blue, ferrous ion Fe2 plus light green, ferric ion yellowish brown, nickel ion green, chromium ion green, manganese ion pink. So you have to memorize the color of these ions in aqueous solution mainly, or acidified solution. And in the among the anions, and the permanganate, it is pink or purple depending on concentration, dichromate ion orange, and the chromate ion yellow. So we must have to memorize the color of the cations and the anions. Okay. Now let's see the original aqueous ion solution with their color. The chromium looks like this, manganese Mn2 plus like this, ferrous, ferric, cobalt, nickel, cupric, and zinc. So these are the color of the ions in aqueous solution, that means in water solution. So whenever addition of limited aqueous sodium hydroxide is added, and what does it happen, let's see. Okay, and the color, how it is getting changed with the sodium hydroxide solution. Okay, so there is precipitation, and the precipitation is there, and the, you know, the white insoluble substances are formed in most of the cases here. Okay, in terms of their hydroxides. So chromium hydroxide, manganese hydroxide, ferrous hydroxide, ferric hydroxide, cobalt hydroxide, nickel hydroxide, cupric hydroxide, okay, and zinc hydroxide. So in almost all these cases, you are getting insoluble PPT, that is insoluble one. But addition of excess of aqueous sodium hydroxide solution, so the color becoming like this, and here we have to remember, so and here the zinc white PPT is there, but here it is clear and transparent, because for zinc in excess NOH it will become transparent, okay, because in excess NOH, and we will see in details with reactions that zinc hydroxide will get dissolved in NOH with the formation of sodium zincate, which is a soluble salt, okay. Now we will study action of sodium hydroxide solution on certain metallic salt solution, and the very first one is calcium. You know, group 2 metal, so calcium nitrate reacting with caustic soda or NOH, and the changes is, so their hydroxide salt will get precipitated, white PPT, okay, and along with the side product sodium nitrate, which is a colorless, and that one is white and sparingly soluble, that is partially soluble, it is not totally soluble one. One similar reaction is taken here, so one calcium chloride salt is taken in place of calcium nitrate here. Similar kind of reaction will follow, reacting with NaOH, calcium hydroxide, okay, the white colored precipitate will come, which is an insoluble one, okay, and that's it. The next one is ferrous sulfate and ferric chloride, that means ferrous and the ferric reacting with NaOH. The similar kind of reaction will again follow, that is the precipitation of hydroxide salt, as these are insoluble, along with the another salt, sodium chloride and sodium sulfate here, and it looks dirty green insoluble, and I will show how it looks, and it is reddish brown. So you have to remember the reaction along with their color change. And you can see the color change, the first one for ferrous and the second one for ferric, okay. Next we will see the reaction of copper, zinc, lead, okay, copper, zinc and lead, and they all react with NaOH with the formation of, in case of copper sulfate, the similar kind of reaction of copper hydroxide will there, and that looks pale blue PPT, and I will show definitely. And the zinc, so zinc hydroxide, white gelatinous white, okay, and zinc hydroxide, that one is again soluble in excess NaOH with the formation of sodium zincate, Na2ZNO2, okay. The similar kind of reaction and is also observed for lead, initially lead hydroxide, and with excess NaOH sodium plumbite, because sodium zincate and sodium plumbite, these are soluble in excess NaOH as they are soluble salt, okay. And the color, it is gelatinous white, and this one is chalky white, okay. Copper chloride solution, and here mixed with NaOH, and you can see the precipitate and how it looks, copper hydroxide. So we have seen, so copper salt reacting with strong alkali NaOH and how it behaves. The pale blue PPT comes of copper hydroxide, okay, which is an insoluble one. And for zinc, it is zinc hydroxide, it is white gelatinous. But you must have to remember, for zinc and lead, these two hydroxides are excess in NaOH, they are soluble, okay, with the formation of their sodium zincate and sodium plumbite salt. Now look at this reaction, ammonium salt, ammonium chloride reacting with NaOH, and there is no precipitation or no those reactions we did here, and here a separate kind of reaction will follow. So any ammonium salt reacting with strong alkali, you are getting ammonia gas, okay, you are getting mainly ammonia gas. After sodium hydroxide, the next we will use here ammonium hydroxide, the weak alkali ammonium hydroxide, and with the same the metal salt, that is ferrous, ferric, copper, zinc, lead. Okay, so let's start with ferrous salt and ferric salt. Can you see ferrous salt and ferric salt reacting with ferrous salt, and how it looks I have shown you. Ferrous and ferric, okay, so it is green and it is yellowish solution, and reacting with ammonium hydroxide the dirty green PPT comes out. Okay, and for ferric
is a message from the future.
And here for ferric salt, the ferric hydroxide reddish brown PPT comes out. Okay, so these are not soluble in excess ammonium hydroxide. Okay, dirty green PPT insoluble, reddish brown PPT insoluble. Okay, so ferrous chloride and ferric chloride when reacting with ammonium hydroxide, so this kind of PPT will come out. Okay, you must have to remember their color and they are insoluble. Next, we will study one of the most important reaction from this chapter, and that is this one, that is the copper salt when react with NH4OH or ammonium hydroxide, the initially pale blue precipitate comes. Okay, so and if that precipitate is allowed to react with excess of ammonium hydroxide, and one complex salt is formed, tetraamine copper 2 sulfate, and it is dark blue. Okay, so two reactions are there, you can write any one out of these two. Okay, copper sulfate solution is taken, and this copper sulfate solution, and here ammonium hydroxide is added dropwise, and you can see the what is the change there. Can you see? Okay, so initially pale blue, and the finally dark blue color is coming out here, and you can see the reaction, and here the initially copper hydroxide pale blue precipitate is there, and the finally you will see the deep blue color. Okay, so that is the very important, and the deep blue compound is tetraamine copper 2 sulfate. Okay, now another important reaction, zinc reacting with NH4OH and ammonium hydroxide. So initially white gelatinous white PPT is formed, and you know all the compounds of zinc are white. Okay, white gelatinous PPT, but with excess of NH4OH that PPT will dissolve, and with the formation of tetraamine zinc complex, and similar to that of the copper one. But in copper, so the color change is prominent, but here not so, because it is white gelatinous white, and it will transparent clear solution. Okay, now as it is a soluble one, now I will show how the color change is there, and you can see, so in the zinc salt ammonium hydroxide is getting added, and the white gelatinous white PPT comes, and that will get dissolved. Okay, white gelatinous, there is a gelatinous PPT of zinc hydroxide. Okay, and now we will see the change of that one, and when excess of ammonium hydroxide is added there, and this PPT is soluble in excess of ammonium hydroxide, and you can see excess of ammonium hydroxide is added there. Okay, and the precipitate, the gelatinous precipitate will dissolve step by step slowly, and that is the reaction. And here, okay, and the tetraamine zinc sulfate is there. Okay, white PPT soluble in excess NH4OH. Okay, with lead nitrate and ammonium hydroxide, so one reaction lead hydroxide is there, and that is chalky white. Okay, that is chalky white in color. Now let's summarize all the reactions of ammonium hydroxide here. Okay, one by one. Ferrous and ferric salt reacting with NH4OH, the color change is there, dirty green PPT, and the ferrous hydroxide reddish brown PPT will comes. Okay, and then copper, as I have said, so one of the most important reaction it is. Okay, so that one on pale blue PPT comes at first, and then it become dark blue with the formation of tetramine copper 2 sulfate. The similar kind of reaction for zinc, but not color change is so prominent as it is for copper. And the next one here is lead. Okay, now we have to study some simple reactions on metal with alkali. Metal with alkali. Can you see metal with alkali? So here zinc, zinc NOH, aluminum with KOH NOH, and lead with KOH NOH. So similar kind of reactions are there. Can you see? Sodium zincate, potassium zincate. Sodium plumbite, potassium plumbite. Okay, similar kind of formula, and that is a bit different. Sodium aluminate, potassium aluminate. Okay, and in all the reactions, you are getting hydrogen gas. Okay, so zinc, aluminum, and lead. Zinc, aluminum, and lead. Okay, so the now if we take their oxides, and what will happen? Let's see here. Okay, can you see here? So zinc, all their oxides are taken, zinc oxide or hydroxide reacting with NOH. The same type of products are there. In the place of their H2 wire there, and here H2O. H2 wire there earlier, and here H2O. The same kind of reactions are there. Sodium zincate, potassium zincate, sodium aluminate, potassium aluminate, sodium plumbite, potassium plumbite. Okay. Now let's move to one very important reaction here. Why zinc is called amphoteric oxide? Why zinc is called amphoteric oxide? So zinc oxide is amphoteric oxide, and do you know why? Amphoteric oxides and hydroxides are those compounds which react with both acids and alkali to form salt. Okay, so that is the definition of amphoteric oxide. Zinc oxide and lead oxide is amphoteric oxide. Okay, and you have to argue with reaction, and here zinc oxide and hydroxide reacting with acid to form salt plus water, and similarly they would react with alkali to form salt and water. Okay, and that's why zinc oxide is called amphoteric oxide. So that is all about from this unit, analytical chemistry, chapter number 4 of chapter number 4. Okay, so thank you everyone. We did the analytical chemistry today. So analytical chemistry mainly reaction based, and I have tried to make it clear to you, and now it's your turn. You have to go through all the details from the text very nicely, and after that you must knock me, okay, for any kind of problem or any kind of type of questions. If you have any query, always welcome. Okay, so just do your study nicely. Okay, and the rapid chemistry is always with you, okay, for your service. Thank you all.